Hello, folks. Welcome to Chapter 6. Happy whatever day of the week it is for you.
Yup. And
Thursday.
don't worry, it is not November and I'm in a tank top. It is July and I'm in a tank top, just
Yeah,
so you know.
it's the second. We've been tearing through these videos like crazy. So, yeah, this is how we spend our summers. This is basically what math teachers do all summer is do math. So.
Math, and all math all the time.
All right, so this section is one I know you probably have done before, so we're going to kind of maybe go fairly quickly. When we have two equations and two unknowns, or what they call a system of equations, there's three main methods that you're probably familiar with: elimination, substitution, and graphing. We're just going to quickly refresh your memory on all three of them. So what do we do with elimination, Ms. Young? What do you remember about the elimination method?
So what we're trying to do here is we're trying to combine these two equations in some way that will eliminate one of the variables. So either I want to add them together and maybe one of the variables will go to 0, or I could subtract them. Your algebra teacher probably told you always add, but you don't have to. You can subtract. You just have to make sure you subtract everything.
Yeah.
So like in this problem, I would probably subtract, but I could change one of the equations if I wanted to.
Yeah, you can also change, like, if I wanted to, right, what Miss Young is seeing is that the y's are the same. So if I have y minus y, it'll go bye-bye or be eliminated, because Miss Young is the eliminator, right? I could have multiplied the first equation, everything in the first equation, by -3 and then eliminated the x's. But that would be more work. Miss Young has just done this enough that she's smart enough to say, oh, let me take the easy way out, okay?
Yeah.
But when you're subtracting equations, you do have to be careful that you are actually subtracting. So what am I going to get under the x's is I have x minus 3x. So below it, I'm going to get a -2x. Right? And then I'm going to get, and you don't have to write this, but I am going to put 0 in place of y just for emphasis at the time being, because y minus y is 0. Normally, I'm never going to do that again. It'll be blank.
Yeah.
And what will I get on the end?
-6. 1 minus 7.
So I have actually the equation -2x equals to -6. And that tells me, I'm sorry, -6. That tells me x is equal to, let me see, 3.
Yeah.
Okay. Then once you have one of those, you take that value back to one of the original two equations and plug it in for x. So me being the smart guy that I am, I'm going to take this into the first equation. So I'm going to take x plus y, and that equals to 1. And I'm going to put, I'm going to put
3 in for x and get 3 plus y is equal to 1. Right.
And now when I solve that, y will equal to -2. And I'm not going to do this every time, but I do want you to kind of understand, all right, so, you know, maybe you can do this process, but what do we actually have is I have the solution now, and this is actually an ordered pair, 3, -2. And if I put that into the first equation, I'm going to get 3 plus a -2. And last time we checked, that equals to 1. And that means it works in this equation up here. Okay? Oh, you and I have, yeah. It's going to be 3 times 3 plus a -2. And that does equal to 7, which means it works in the second equation. You don't have to do that. I mean, you can do that mentally, but I just went ahead and did it for the, sake
and
of
it does work. It has to work in both equations. If it works in one and not the other, then maybe you made a mistake in your second computation. But it does have to work in both equations.
Yeah, so it's a way of checking your work to make sure that you do indeed actually have the right answer. And then if you check your work, it makes it easier on us, because the two best kinds of papers that check are the ones that are
0 and 100.
it's like, oh, right, it's really easy. Yeah, 100% is easy for us to grade. And if it were, if it's blank, so either get it perfectly right or just leave it blank if you want to
Yeah.
make our lives easy. Okay,
Yeah.
that'd be fine.
We prefer that you get it perfectly right, but
I don't care. I don't care. I just, one of those two options is.
he does care. If you got it, listen, if you turn in a blank page, you would get a phone call from Mr. Bobby.
Yes,
He cares.
all right, but seriously, all right. So anyway, I don't know where I was going with that, but all right, let's talk about the idea of substitution. The first one, the elimination, is to try to remove a variable by combining the equations through addition or subtraction, or some multiple of an addition or subtraction. Substitution is where you have one of the equations solved for x or y, or can easily solve an equation for x or y, and then you put it in that place in the other equation. It's like in a soccer match when one player comes out and then another player goes in. They're not the same player, but they play the same position, okay,
Yeah.
and they do the same function. So
I'd like to tag out the y in this equation. Can I tag that out? Put something else in for him?
yeah, I don't want to have another y in there. So I'm going to take this equation right here, and this one I could easily solve for y by subtracting the x. So y would equal to 1 minus x. You cool with that?
I like it. I like it.
You like it? All right, so this part right here is going to go in that place where Miss Young wanted to tag it out. Okay, so I'm going to now have the equation 3x, and I'm going to have 1 minus x. And these actually are very carefully constructed problems that don't have ickiness in them. I knew what I was doing when I made these lessons, right? 3x minus x is 2x.
So the goal here, as he's going through and solving this, is to make one of the equations have only one variable, right? Right now you've got two equations with two variables, and we want one of those equations to only have one variable. And that's why we're trying to tag a variable out. We want to pull y out and put something with x's in it so that we go all the x's.
And now once I've done that, then it's easy peasy, okay? And I work it out and I get x equals 3, which is exactly what I had like a few minutes ago. And then if I put that 3 in place of the equation that I had boxed up there, I'm going to get y is equal to 1 minus 3, which is -2, which I hope I'm right.
We already checked these. So
we already checked this, and those are the same answers I had the previous slide. I don't care. I mean, I know we better get the same answer, okay? Regardless of the method you use, we better get the same answer. But I want to remind you of these methods, okay? All right, and then the last method we are going to talk about is graphing. And there's a couple different ways of doing this. I am pretty terrible at drawing a line. I think we've already established that. I can graph x plus y equals 1 by doing the x and y intercepts, except I should grab my pen. I can put a line, I put a dot here at 1. If x is 0, 1 is a point on there, and 1, 0 is another point. And then I could try to draw a line, but I kind of stink at drawing lines. And then the next one, the y value, the y-intercept, if x was 0, it would be 7. And then if the, let's see, if the y value was 0, then x would be 7/3. So I got to plot 7/3, which is 2 and 1/3. Okay, so it's like right there somewhere. And then I got to like connect these two lines. And I know I could solve this for y equals mx plus b. And then I could graph it. And it looks like the point is, hey, you know what? It looks right there. You know what? You know what the key is to good graphing? Big points.
Really big points. Somewhere in here.
Somewhere in this area, okay? Now, I know that wasn't really refined. Oh, did you actually use the line tool?
Yes.
And stuff? Okay,
Yeah.
use the actual line.
Because it's there.
Yeah, well, whatever. This is not exact, okay? Now, that point turns out to be 3, -2. And I did roughly a good job, but I can't confirm that with this talent. or lack of talent that I have. So what we're going to do is you are more likely to use graphing when you are using a calculator, or at least I find that I am. So I'm going to go and make a new document. And we've used the calculator, Inspire, a few times before. So I'm going to go over and dump what I was working on. I was working on some big fractions. And I'm going to graph. Now, if you've used an 84 before, a TI-84 for a lot of your life, you can't do this. You've always been told you have to solve the equation for y. And that's fine. And I could do that here, but I don't have to. If I press delete, I delete the equal sign. I can do inequalities, but if you notice, I can go down to number 6, and there's an option called relation, number 6. And when I choose that, now I can type in the equation as it appears. It doesn't have to be solved for y. So if I remember right, it was x plus y, and it equaled to 1, and it will make a much better graph than I did. Okay?
Pretty.
That gets two twirly fingers. And then if I hit tab again, I can still on the relation mode, I can do, help me out, it was 3x?
It was 3x plus y equals 7.
Thank you very much. I asked Miss Young to write that down because I have, I'm older than her, so I'm going to start forgetting things, All right, so now I have the graphs, and I can find where they intersect by doing the menu, analyze graph, intersection. And then I go to the left of it, go to the right of it, and I get the value. Same value, third way. Now, I can estimate that based on my graph, but, I can't use no fancy line tools like Miss Young, so I had to guesstimate it, okay? All right, so that's not what I want. I don't want go back to the actual presentation, Mr. Bowden.
You don't want to go to Google? The Googles?
To the Googles. All right. Hey. I'm the one who says that, not you. All right. There's a couple special cases. You want to do the one on the right and I'll do the one on the left, or do we want to?
Sure. And you guys might want to pause it now and try this on your own. Yeah,
try to solve these on your own. I'm going to do the one on the left with elimination, and I'm guessing Miss Young will do the one on the right with substitution.
Yep.
So, all right.
And now would be a good time for you guys to fast forward us because we're being boring.
Yeah, we're being boring. We're just doing algebra, except that's kind of what we do. We do algebra.
You can put us on double time right now if you want.
Yeah, well, they've been watching us in double time all year. What are you talking about? 0.
No way. We're so speedy and fast.
Hey, I listen to.
No way.
I listen to books on tape at, I listen to books on tape, podcasts and stuff on 1.5 speed.
I have to say, really? You got a tape deck? You are.
Books on, or, podcasts, well, the ebooks or whatever. All right, now we both have like goofiness going on. These are called special cases, but we actually, I think, talked about these kinds of things. What happened with equations when we got like a number equals a different number or a number equals itself? Well, we talked about that. Those are the two special cases we saw with lines. Those still carry forward here. If I get one number equals a different number, that's a false statement. 0 ain't equal to 15, so this is no solution. What did we say it was when we got the number equals itself?
Same line. So it's every number will work.
Okay. So it's there's a special word we called it. We called it an identity.
Uh-huh.
Okay. But if you said same line or infinite solutions, you're all good. Okay. All right. So this is, like I said, this isn't the worst lesson in the world. Okay, but you know what? Miss Young likes her word problems. I would never give you a word problem if it wasn't for Miss Young. But
I feel like you should stop making me the bad guy in this scenario.
I don't know. Well,
You've been doing it all year with them. Miss Young, the bad guy.
Well, you're the one who makes fun of me, so whatever. Anyways, all right. So we got some concert here, and you can get the premium regular tickets. Like, it is July 2nd, so like Hamilton's on Disney Plus. So if I was going to go see Hamilton, like if I actually went to see it, I could get floor tickets for like $2,000.
Right.
I could get balcony tickets for about like 1,000. Okay, yeah, but that's not what we're dealing with here. But that's what it
We
is.
should have looked that up and used that
I
information.
know that would have been a lot better than this made up ticket price. But you get $22 for regular tickets. I'm sorry, for premium tickets, 22 and 12 for that. We see that the season opener they sold 5,212 tickets, and they collected 76,114. So we need to come up with the equations ourselves. Well,
Call premium tickets P and regular tickets R.
okay, so we're going to use P and R. And I know that those tickets together, they sold 5,212. So
Yeah.
I'm just going to mash those together, and mashing things together is addition. So P plus R equals 5,212. Okay, now I got to think a little harder. What I haven't used is the prices, right? So if I sold one regular and one premium, I would make how much money?
$34.
$34. And you got that by taking those two. What if I sold two regular tickets and two premium tickets and one regular ticket?
Then I would make $44 in premium tickets, $12 in regular tickets. So 44 plus 12 is 56.
Okay, so where'd the 44 come? There ain't no 44.
I multiply times 2 for
Okay,
2 tickets.
so we would take the number of premium tickets times 22. So 22 times the premium. And then I didn't like up the ante on the regular, but it would be $12 per regular ticket, right?
Mm-hmm.
Oh no, these numbers are going to be icky. And that equals, what is it, 76114? We're going to need calculators here, I'm sure.
So guys, you might be tempted to just type this into your calculator in graphs. And actually for this problem, I think that would be more work because you'd be working so hard on trying to make the window work for it because of those huge numbers.
Yeah, I mean, I could, but I know that because there's 5,000 total tickets, I'd have to like really expand my window, and I could do that. It'd be fine, but it's really not that bad. What I probably would do is do the substitution, take away that P and plunk 5,212 minus P in for R. Now, I could have also multiplied the first equation by, let's say, negative.
Would you rather do that? Let's do that. We can do elimination.
No, we can do either one. I don't care. You were halfway done, but we'll go.
Nope, it's too late. I've already,
Okay.
I've done undid it all.
You done undid it, huh? Okay. So if I take that one times 12 and negative 12, and why I'm doing negative 12 is so that I'm trying to make the R's go bye-bye. Miss Young was trying to do the same thing too, was trying to make the R go bye-bye. So I'm going to get negative 12P minus 12R. That's not supposed to be in. Oh, now we need a calculator. Let's find out what 5,212 times 12, negative 12 is. 5, 2,
you say it. You say it, I'll write it.
It is negative 62544. And that's supposed to be like a subtraction there. Okay. But the R's are going to go bye-bye, right? When we subtract there, and we're going to have, God, quit writing on top of me.
Sorry. I'm going to back up. You just keep doing you, boo.
All right. So I'm going to have 76114 minus 62544, and that's 13,570. And I like dividing by 10.
Yeah, just take the 0 off the end.
I take the 0 off, so that tells me that the P's are 1357.
They sold 1,356 premium tickets. You know how I knew quickly that it was premium tickets? Because I named P after premium.
Oh, you're so smart. And this is going to be 5,212 minus that number. 5,212 minus 1356. I know I can do the math by hand, but I'm not going to.
I wouldn't either.
This tells me the answer, that was supposed to be a 7 up there. It'd be 3855. That's the R. Okay? So I know, I mean, the numbers are icky, but you know what? We're going to learn ways of dealing with even ickier numbers. This was just really almost, I feel like this could have almost been a flashback video.
Yeah, definitely.
Yeah, so hopefully this wasn't the worst thing in the world for you. And we do have some problems for you to practice. And that's all she wrote. Happy
Thanks,
whatever day.
guys.
Bye.